Okay, hi everyone. Okay, we are from Group One. Okay, there are three members in our group, which is Shavinas Vijayan, AF210140, myself, Darsan Rao, Nalalaki Subramaniam, CF210363, Gerard Lester, Betty Newton Kamal, CF210348. Okay, our topic is about movement distribution method for indeterminate truss and frames. Okay, for the chapter one introduction, in this presentation, we introduced the groundbreaking program for statical indeterminate beam and frames analysis, guided by the program development life cycle, developed in a collaboration with civil engineering professionals and students. Okay, the program focuses on calculating reaction forces using the moment distribution method. It serves a comprehensive solution streamlining analysis task for the civil engineering community. Okay, the PDLC ensures a systematic approach from a design to ongoing maintenance. Envision a future where structure analysis simplify and efficient with our program leading the way. We look forward to making this transformative tool accessible and invaluable to civil engineering. Thank you for your attention. And the future where complex analysis becomes seamlessly manageable. Thank you. Okay, for the problem statement, there are three problem. Okay, first of all, designing the program. To answer the problems, we use a method such as flowchart and pseudocode for the purpose of providing the guidelines to help in the design phase of the program. Okay, the second one is coding implementation. At this phase, we started creating a creating a program code as planning in the program design phase. At this phase, we started using the Python software. Okay, the third one is about program testing. In this phase, after the code is written completely, we run the program to make sure the program properly produce the required output and appropriate data input. Okay, in our project, there are few objectives we have been succeeded, which is the first one is about to determine the moment distribution method suitable for solving indeterminate beams and frames. The second one is about to identify the reaction of a beam of A, B, and C, which are the supports and then the force loads. Okay, the third one is about implementing the knowledge by using Python programming language. Okay, for chapter two, literature review. Okay, first of all, we emphasize a Jupyter Notebook pivotal role in seamlessly integrating real-time code, equations, visualization, and text dynamics document creation. The literature review highlights the Jupyter's versatility, supporting Python, R, and Julia, and enabling interactive experimental even on the mobile devices. Okay, then we delve into a Jupyter significant in computing moment distribution force A, B, and C, marking the shift from manual to computational solution in structural analysis due to the increasing system complexity. Okay, Python emerges as the key language for its efficiency, serving an invaluable tool for both students and engineers navigating integrated structural system. Okay, the second one is about before delving into the Jupyter notebook coding, we essential to develop a computer algorithm. This typical involves this typically involves creating pseudocode and flowcharts, utilizing the natural language and visual, visual diagrams to represent the algorithm logics and flow. This pre-coding step serves a crucial reference points, aiding the transition from algorithm designs to actual coding within the Jupyter Notebook environment. Thank you.
Chapter 3 Pseudocode and Flowchart. We begin the program by displaying the welcoming message and getting the user's detail, such as the user's name, metric number, and date. Then we proceed by telling the user the function of this program, which is to calculate the moment distribution method. Then we get the user to input the length of span X, Y, and Z in meters. Then we get the user to input the uniformly distribution load A, B, and C in kilonewton per meter. Then we're going to define the input X, Y, Z, A, B, C for it to be used into the formula for fixed end moment, stiffness factor, and carryout factor. Then we're going to define the constants for Young modulus and moment of inertia. Then we're going to calculate the final end moment using the moment distribution function. And then for the output, it will display the final end moment for each band. Lastly, ending the program. This is the flowchart. So to start the program, we declare the variable length, load, elastic modulus, and moment of inertia. Then we ask the user to input the variable x, y, z, a, b, c. Then we decide whether it is true or false if both distance and load is less than 0. When it is false, it will become an invalid value and will return you to the input variables. But when it is true, it will calculate the fixed end moment, stiffness, and moment. And if the distribution is balanced or equals to 0, it will calculate the moment and reaction force. If the moment and reaction force is greater than 0, it will display the force upward and moment clockwise. Otherwise, display reaction force downward and moment anti-clockwise. And it will end the program.
Okay, so for chapter 4 we will take a look at the result of Python program. So program user manual requirement, it requires, this software specializes in executing the moment distribution method precisely tailored for solving indeterminate beams and frames. It incorporates fixed end moments, stiffness factors, and also carryover factors with accuracy. Okay, so taking a look at the procedure, we have 12 procedure in total, and this page covers 6 procedure. So it covers, the first step is introduction, so begin the report with welcome message. The second is user details input. So we start the program by displaying like a sort of welcome message. Then the third step is program purpose, include a message to inform the user about the primary objective. Span length input, so we have to input the length of 3 spans x, y, and z. Load input, request the user to input uniformly distributed loads on each span, which is a, b, c. And step 6 is import library, so we have to import the necessary numpy library for mathematical purpose. Okay, and step 7 is the function definition, so we have to define moment distribution function. Step 8 is the constant specification, so we have to specify the constant of Young's modulus and moment of inertia. And step 9 is the calculation process. Step 10 we will get the output and the final end result. Step 11 is the conclusion, so to summarize the findings of the moment by the moment distribution method. And step 12 is the closing remark, so we have to conclude the report by expressing our gratitude. Okay, so this is the user manual guide, which is basically like an overview guide on how this program works. So as you can see in this page, everything covers the value to be entered for the length of span x, y, and z. And this page will take a look at the to enter the uniformly distributed load on span x and span y. So we have to insert the value based on these pictures. Okay, and then we will take a look at the final 2 steps, which is entering the load of span uniformly distributed load on span z, and we will get the final answer, which is shown below, the final end moments. So after getting this, we have successfully used this program based for its usage of calculating moment distribution method.
For recommendation, the program's development can be expanded by incorporating features for calculating moment distribution in diverse structure designs, enhancing flexibility in unit selection and input values. Additionally, a user interface redesign is recommended to address privacy concerns, align with user expectation, and provide a more organized approach to program development, ultimately aiming to improve functionality and user satisfaction in moment distribution calculator. To conclude this presentation, computer programming, especially with Python software, is integral in computer science and technology, particularly in software development. Python's flexibility and portability across platforms make it adaptable for civil engineers, enhancing efficiency in tasks such as determining structural reinforcement in slabs. Its integration with tools like AutoCAD and BIM software streamlines design processes, automates tasks, and optimizes workflow, ultimately boosting productivity and decision making in civil engineering projects. Thank you.